All right, this is our continuation of our September 9th series in 2005 here in Chico, California. Um, Trying to cover up my hair. I need a haircut, but I'm really low on finances, which is why I'm recording on my cell phone. Now, in the last video, we began with one of two examples that I promised for the collapse of the wave function. The studied phenomenon, I believe it's correct to say, it's generally conceded to be at the electronic level, the electron level. Because electrons can be coordinated, and in fact, so can photons. Because they're pure energy. They're pure energy. The proton is a spatial particle, but the electron and the photon are not exactly spatial. One thing we can say is that the photon is in a completely different state than an electron. However, it is known that electrons do produce photons. They evolute out of an electronic shell in a typical emission process, although that is not the only way that photons are produced. Photons are, of course, pure energy, and that's why they're not affected by gravity. And the photon is also said by Sir Roger Penrose to not experience time, which is one of the most profound, pithy statements I've ever heard a physicist say in modern times. I'm not sure that he fully, or I should be guessing is Sir Roger's mind, but it's hard to, he said it so offhandedly, just the photon does not experience time. Well, I really thought about that, and that matches what I discovered as well. That actually the photon exists in the space in which time is manifested, which it sounds like some gobbledygook, like some circular argumentation. It's unavoidable to encounter some irrationality in attempting to put this into words. That's the nature of a paradox. But I've got it. I've got the actual solution. And it doesn't appear as obviously, I don't think, in the phenomenon of entanglement, although it's exactly the same phenomenon. Entanglement means that there are two particles that are coordinated. Now, normally that's said to be entangled. That's the wrong word. Entangled means it's complex. It's anything but complex. You can state very tersely, what is the relationship of those two particles? They're in a coordinated state. And the reason you can say coordinated is that they share a state. They share it. And this is the essential nature of superposition. That normally a state has to be localized. Really, it has to have a center. It has to be associated with a particle. And in this case, it's two particles, but the relationship between the two particles is not spatial. You can see that there is a spatial separation that can be measured. So there is a spatial separation, but they're not separated in event state. So they actually share the same event. And this is the superposition of Schrödinger's cat problem, his cat Gedanken experiment, which we covered in the presentation prior to this. Now, the main example that I made my discovery by researching light, it was one of the reasons that I got into cosmology and quantum mechanics, is because of the nature of light in astronomy. Obviously, light is the major source of information we have for the whole universe. We also have gravity, and that has been extrapolated quite broadly, and in some cases quite mistakenly, as in the case of the supermassive black hole. That's a misconstruction of the concept of gravity, as I'll be showing you as I show you quantum gravity. We already discovered the quantum of gravity. That's the proton. That's the quantum of gravity. It matches every description of a quantum. And so it is the quantum of gravity, because there's no other source of gravity in the universe except for the proton. Now, in the case of the photon, you have the exact opposite, but it's conjugally opposite. So it's another perpendicularity. This is a conjugation series, a series devoted to conjugality. And light speed is a conjugal number. And the concept of wavelength and frequency is a conjugal relationship. And the relationship between the proton and an electron in their shell system is conjugal. It's orthogonal in spheric space. So what we have is a particle that does not behave the way a proton does, because a proton makes a center, the electron does the opposite of that. It's conjugally opposite. I have to say opposite because we have no word for half opposite. But that is the definition of conjugality. It's not polaric opposite plus minus. It's geometrically half of that. So the two quantities have to be conjugated, and that's a mathematical term. They are conjugal in every example I've just given. And I gave about 10 4 lectures ago. Now, in this presentation, I want to give to you the collapse of the wave function in canonical form so that you'll see it. And you'll be the first person to see it besides myself. This answers all the paradoxes, so this is going to be extraordinarily difficult to convey in words because it's pure synthesis, which requires coordination of ideas. It's not sequential. It's more of a ring formation where you're getting more than one perspective on the same thing until it gels. It solidifies. You suddenly have an aha moment. So what we want to look at is the nature of light transmission, which is quite mysterious. It is said to have a constant speed. Is it the speed of what? It's considered to be the speed of a packet of energy, and that's known as a photon. So a photon is a packet. It's not exactly a particle. In fact, it cannot really be said to be a particle when it's in transit because it has no corporeal form. It's a pure wave form, and energy is exactly described as a wave. Energy is. An electron, things get difficult because it has a locality. In other words, it's not just expanding. What's happening when light expands? Can you explain that? Nobody has explained it yet, but I will attempt an explanation because it will lead into our proof of what is the collapse of the wave function. The collapse of the wave function actually refers to a sphere, a spherical function. That was proved by Christian Huygens about 4 centuries ago. So that's well known, that light is a wave. It's not a particle. What happens is that when it's absorbed, it instantaneously has a particle form. In other words, it has a position. We can measure its position when it's absorbed. We know where it's absorbed. We don't know exactly how it's absorbed. And the way we try to describe how the photon, which is a wave, collapses to a particle, that's the collapse. It's when it stops being a wave and has a position. And that's called absorption. It has this same characteristic when it's emitted, where it's part of an electronic shell in the situation I'm choosing. Photons are produced by various means, but the general way, for instance, in a star, that a star produces its light, is by emission from electron shells. Generally hydrogen, obviously, because a star is mostly hydrogen. But what happens is that the electron changes energy level. And when it does, either going up or down, it either is absorbing a photon or it's emitting a photon. And that's called absorption and emission. Now, the phenomenon of emission is the evolute of a photon. In other words, it detaches from a spherical system, which is essentially the proton-electron relationship. It detaches from the electron and becomes a different manifestation of energy, which is in free flight. It's actually in free fall. It's falling. And it's not impetal energy. Even though light is said to have a velocity, it's intrinsic. the energy state of a wave is that of a particle. So it has an energy state, but it can't be said to be in space except it's falling through space, but it's coherent. So it's in another space. It's actually one space translating itself through another space, and the other space that light transmutes through is called spatial space. But it doesn't really affect space. So it's not interacting with space. There's no ether. Instead, what there is a conjugal relationship that is intrinsic to the energy state. And when that is locked, either as an electron in a shell or an electron as a localizable particle, it's in one state where it has a sort of position. In the electron shell, it can't be said to be in any one position in the shell, but the shell has a relative position with respect to the protonic core. So it is conjugal, but it's an entire domain that's in conjugal relationship with space. And that's energy. So energy is conjugal with space. And that's a major insight that improves on Einstein's insight. He got the linear solution, and so he identified time as a derivative component of energy without fully realizing that's what he was doing. He was stuck with linear algebra, and that's always the backbreaker, because linear algebra doesn't work. It doesn't work for these computations. You need a different number system that I've carefully described over the past 5 videos. And this isn't the first time I've done it. I have 1,200 videos where I've attempted to explain this many times from many angles, which is kind of a pun in geometry. An angle or a point. Get to the point, well, it's a geometric term. So there's a lot of those. Anyway, when light travels, it's in free fall. It doesn't have impetal velocity. It wasn't fired. What it did was it detached from a locked system, the electron in this case, and it simply falls. And it falls in a spherical form. So it's occupying a different space than space. It's not occupying space anymore in the intrinsic sense. It has no locality, but it does have it has a presence in space, which we learn of when the photon is absorbed by our eye or our photographic plate, taking a photograph of a star or looking at a star. The photon is collapsing as it enters your eye or the photograph. It collapses. It was a spherical wavefront, and then in no time at all, it collapsed to a point, which defies relativity. That's because it's non-relativistic. It's not a relativistic phenomenon. It's simply doing what it does in its space. It was always a particle, and the particle was falling, but it's falling in another dimension. So it's falling out. In other words, it's anti-gravity, and it's anti-gravitational with respect to its source. It's instead of being pulled in in an atomic system where the electron is locked into that geometry. So it does have a locality because it's related to the proton. But when a photon detaches, it's no longer related to matter. And so it free falls through the other dimension for the edge of space, which for it is a point. It's trying to reach the other point in its spherical orientation. And now that it's no longer being pulled in by a centripetal force, it simply falls. And its natural motion is dictated by the rotation of the universe, which is a 4D rotation. Except you can't say 4D, because that's a 4-line system. It's not falling through a 4-line extrinsic grid. It's falling through an intrinsic space that's latched to spatial space. So space has a non-spatial dimension. That's a major discovery that I made. So the collapse of the function happens like this. It's called the collapse of the function because a wave can only be described as a function because it has no position. A wave is an extended phenomenon. And it's curved. It's curved on itself due to a conjugal relationship between wavelength and frequency, which is conjugal strict. It's orthogonal. And this is the basis of Einstein's incredible insight, that he was able to orthogonalize time with space. Space having already been linearized, he's linearized time with linearized space. That's not what we want. We want the actual geometry, which is spherical, obviously. So Huygens did prove that. So the spherical wavefront goes out from its source, and it's falling to the common edge. It's falling in a straight line. And you can prove that when you get the photon. When it arrives, it seems like it came in on a straight line, when actually it arrived as the entire sphere. And then we extrapolate backwards where it came from, because we can tell what direction it came from. And that's because of the radius of the sphere. You're sighting down the radius. So it always goes back to its center of origin. A bit redundant, but it's the center and it's its origin, which is a center. But it's going anti-gravitationally away from its origin in order to reach its edge. And what is propelling it is intrinsic rotational velocity that we can't see because we only see space. So we don't see the universe rotating, but it is. The entire universe has an angular momentum component. I discovered that. That's, of course, the most important discovery in the 21st century. And I have a whole list of these discoveries. But the collapse, and we've already covered the quantum of gravity, which I will return to in order to discuss the general notion of quantum gravity, which is not quite the same thing as the quantum of gravity, which is the smallest unit of gravity. That's a proton. But the electron has no fixed quantity. The proton does. It's a spatial particle that bends space. But the electron does nothing to space. It actually ignores space. And so as it free falls, the force that's driving it is the rotation of the universe. So it's actually falling to the centrifugal edge of space. It's being thrown out as from a merry-go-round. It's thrown out. Once it detaches, it's now subject to the natural process in the domain in which it lives, which is essentially what we call time, but it's more accurately called event space, where time exists in that space. But we think of time as being localized. Certainly, Einstein used it that way, that every point in his geometry has a time component. That's the meaning of the 4-component number for spacetime, is one of the components is time itself. Well, time actually exists in another domain. It's non-spatial, and this is the mind blower. This is the source of the paradox, is that we can't see the domain of energy, which is motion, which is time. Time is a derivative of energy. And the other derivative, we call it frequency, which is a time term. Frequency refers to temporal reality, not spatial, because frequency is more or less in place. It's a closed system. But when you have a frequency, you have its reciprocal called wavelength, which is a spatial term. But it's spatial in a circular closed system. So it's not our concept of distance. Rather, it's a concept of duration. Frequency is one aspect of the duration, but the duration has to be correlated with space, and that is wavelength. But wavelength is it's on a closed line. Wavelength does not occur linearly. There's no such thing as linear wavelength, just as there's no such thing as linear frequency. They're conjugal in spheric space. Now, the sphericity of space, we can only see the spatial aspect. We can't see the perpendicularity between space and event space, because we only think of space as position space. And this goes down to the Heisenberg uncertainty principle. When you try to measure motion, which is momentum, and try to fix it to a position in quantum space, which would be a particle, you simply can't, because they're incommensurable. Although they're at right angles, we do know that, so they are commensurable, but only one aspect of this orthogonality is what we can perceive. To the proportion that we're seeing space, which is how we see, we are not seeing in time. And you can do experiments with your mind to shift between position space and event space. And with a good mind stretch, you can really change your consciousness that way. Well, the photon exhibits that change of consciousness. It may not have consciousness, I'm not saying that, but the analogy is apt. That the photon is a wave, but in its intrinsic space, as it's traveling, it does not think of itself as a wave. It thinks of itself as a particle that's falling, but that particle is superimposed on itself, and that's superpositional entanglement, which now you know it's superpositional coordination. The information is kept intact, and there's a whale of a lot of information in a photon. We know that from spectroscopy. And that information is retained. That's why we can see a star so far away. It's because it doesn't lose coherence, which means it has an intrinsic space in which that information is retained. And that is, from our positional visual aspect, is a distributed point. And that's entanglement. It's entangled with itself on a spheric surface. It's actually doing what it always did, and we simply imagine that sphere is expanding. But from its own point of view, it's simply falling in a straight line. So that's the nature of the collapse of the wave function, is that when the photon goes out as a sphere, it has to hit your telescope because it's going to hit everything in the universe all the way out to the edge. Now, there's an energy loss when it's absorbed, so there is transluminality. But you see, it's not transluminal because it actually is light speed. It's light speed itself. It doesn't have a speed, but it manifests speed retroactively to us to the same degree that it retroactively indicates distance on the radius back to its source. But what hits your telescope is the sphere, which then collapses. From our point of view, it's transluminal. It happens instantaneously, which defies general relativity. Well, of course, it's not relativistic. So that's the answer. And stay tuned, we'll be back with more. I have a lot more that I want to share with you before I pass off the scene. And so that's why I kind of rush a little bit. And that's also why I continue to make these videos even without my computer. Because I'm running out of time, and you need to know these things. Somebody needs to know them so that you can carry on. Thank you for tuning in. It means a lot to me. I hope it means a lot to you. There's a lot more to come. Stay tuned. Thank you.